Hi everyone. In today's lesson, we're going to talk about more motion. Today is the last day. We'll call this motion day 3. So acceleration. Acceleration is a positive or negative change in velocity over time. And the acceleration is defined as the derivative of the velocity or the second derivative of the standard position. And remember that standard position can be written with the x or the s. Now, if you have positive acceleration, that just means you're moving in a positive direction, moving right, and you have a positive change in velocity over time. This happens when the acceleration is greater than 0. You have a negative acceleration when you're moving left, and you have a negative change in velocity over time, and this is when your acceleration is less than 0. Now, if you want to find out where you're slowing down or speeding up, slowing down is when the velocity and the acceleration have different signs, and speeding up is when the velocity and the acceleration have the same signs. I'll explain this. I know it's a lot to take in, but you really have to, in order to determine these two things, you have to compare your v of t and a of t number line. And then last but not least, if you want to find the instantaneous speed, speed is the average rate of change of the distance over time, and you can find the speed by taking the absolute value of the velocity at that specific second. And we're going to go through an example of this in just a minute. I just wanted to make sure that you had all of the definitions. Okay, so here's our example. It says a particle moves along a horizontal line according to this function when t is measured in seconds and s of t is measured in meters. So it says first find the acceleration function at any given time. So if I'm just going to write s of t, I'm just going to rewrite it, is 2t to the third minus 15t squared plus 24t plus 8. We can find our velocity function by taking the derivative of the standard position. So that would be 6t squared minus 30t plus 24. Then if I want to find the acceleration function, we're going to take the derivative of the velocity. So the derivative of velocity is 12t minus 30. So it's like going down from each one, we take the derivative of each. So this is your answer to part A. This is your acceleration function at any given time t. So now part B, what is the instantaneous acceleration after 4 seconds or at 4 seconds? So what that means is at exactly 4 seconds, what is my acceleration going to be? So we're going to plug 4 into my acceleration function. So 12 times 4 minus 30. So 48 minus 30 is 18. So acceleration at 4 seconds is 18. And if you want to use proper notation, it would be meters per second squared. Okay, so part C, I'm asking you, when is the particle speeding up and when is it slowing down? So what you have to do to figure out this answer is you have to compare your V of t number line and your A of t number line. So I'm going to break this up into two parts. So the first part is to find where V of t equals 0 and make a number line. So our V of t function, I'm going to use the color that I've used up here. So V of t is here in red. So I'm going to set my V of t, 6t squared minus 30t plus 24. I'm going to set that equal to 0. So it looks like I can factor this by taking a GCF out of 6. I'm left with t squared minus 5t plus 4. And I can factor this using add multiply. So t minus 4 and t minus 1. And when I do a t-chart, the 6 equals 0 gets rejected. So I have positive 4 and positive 1. So now that we have that information, I'm going to put that on a V of t number line. Remember that time can never be negative, so you always want to include time equals 0. Then we can put time equals 1, and we can put time equals 4. And we need to test our values into our V of t function. So let's plug some numbers in. So between 0 and 1, we're going to have to unfortunately use a decimal. So let's do v of 0.5. Between 1 and 4, we could use 2. And after 4, we could use 5. So remember, all you really have to do is plug this into your y equals, and you can get your values, or at least most of them. So you can get the 2 and the 5. The v of 0.5, you may actually want to plug in, only because I don't know that the calculator will give you a 0.5 in your table. I can show you tomorrow how to change that because the calculator can actually do it. But for now, we can plug in 0.5 into here. So to find that would be 6.5 squared minus 30.5 plus 24. So take a minute and plug this one into the calculator for this, and then to find these two, you can plug this into the y equals. Pause the video and then hit resume when you're ready for the answer. Okay, so for 0.5, I got a positive value, positive 10.5 to be exact. And for f of 2, I got a negative, or negative 12 to be exact. And for v of 5, I got positive, or positive 24 to be exact. Okay, so that's the first part. Now, the second part we need to do is make an a of t number line. So same thing, we're going to make a of t equal to 0 and make a number line. I think I used blue for a of t, so we're going to use the same thing. So the a of t function, if I scroll up a little bit, we can see that the a of t is 12t minus 30. So 12t minus 30 for a, set it equal to 0. So to solve, we're just going to add 30 to both sides. You don't have to factor this because it's linear. So you've got 12t equals 30 and divide by 12. Now, I don't think they're going to go in evenly, but you can divide them both top and bottom by 6. So if you do that, you'll get 5 over 2. Now, it would be helpful if you knew the decimal equivalent, so you knew where to put that on the number line. So just know that 5 over 2 is equivalent to 2.5. So what we're going to do now is we're going to make a number line for that. So same thing goes. We're going to need to put time equals 0 because time can never be negative. And then you're going to put 2.5, probably somewhere in the middle. So here is fine. And we're going to test some values. So in between 0 and 2.5, I'm probably going to test 1, so a of 1 this time, because you have an a of t number line at this point, right? Because that's the line that I'm making for a of t. And then after 2.5, I could probably use 3. So we'll use a of 3. So now take a minute and plug this into your y equals and figure out what a of 1 is and what a of 3 is. Pause the video and hit resume when you're ready for the answer. Okay, so for a of 1, I got a negative value, negative 18 to be exact, so that'll be negative. And then for your a of 3 value, I got a positive 6. So in order to figure out where the particle is speeding up or slowing down, you actually need to compare these two number lines. So what I'm going to do is actually just copy them below over here, and you can follow along with me. So we have our v of t number line first. And we're going to recopy it that we have time equals 0, we have time equals 1, and we have that time equals 4. Then underneath that, we're going to put our a of t number line. And on our a of t number line, we have again that time equals 0, and we have that time equals 2.5. So you want to make sure you put the 2.5 where it belongs in respect to this number line. So if I have 1 and 4, 2.5 is going to go somewhere in the middle. So when you label it, you want to make sure that it's in chronological order and put 2.5 here. And then follow all of your signs. So copy that you had a plus, a minus, and a plus. And then we have minus, and then plus. So when we're comparing these two number lines, what we want to do is kind of make barriers wherever there's an equal to 0. So time equals 1, time equals 2.5, and time equals 4. So by putting these barriers in, it's going to be easy to compare the values. So we know that a particle is speeding up when we have the same signs. So I'm going to put same for speed up. And we know that a particle is slowing down when we have opposite signs. So let's compare. So between time equals 0 and time equals 1, I have a positive and a negative. So different signs means I'm slowing down between 0 and 1. So now let's look at the second spot. I have from 1 to 2.5 where they have the same sign. They're both negative. So that is where I'm going to speed up. So from 1 to 2.5. Then if we go to the next section, we have 2.5 to 4, where I have a minus and a plus, different signs. So I'm going to slow down there. So union 2.5 to 4. And then last but not least, in this section, from 4 on, I have both positives, which are the same sign. Therefore, I'm going to speed up. So that will be from 4 to infinity. So here are your answers for part C. Now, last but not least is what is the particle speed at 3 seconds? So we know that speed instantaneously at any specific value can be found by taking the absolute value of v of t. So in this example, we need to find the absolute value of v of 3 because they care about 3 seconds. So we actually have to go back up to the top, find our velocity function, plug this into our y equals, and find out what it is at x equals 3. So take a minute, pause the video and do that, and hit resume when you're ready for the answer. All right, so when I plugged it in, I got negative 12. And we know that the absolute value of negative 12 is positive 12. So by definition, the speed at time equals 3 is equal to 12. Now you can use proper notation and write it as 12 meters per second squared. All right, that's it for today. If you guys have any questions, jot them down. Otherwise, we'll see you in class tomorrow.